Okay, this is going to be a quick tutorial on scientific notation. And what scientific notation is any number between 1 and 10 multiplied by 10 raised to some power. So what I mean by that is, if we look at this example, 7.75 multiplied by 10 raised to the 40th. So we meet the criteria of having a number between 1 and 10. 7.75 is between 1 and 10, and we're multiplying it by 10 raised to some power, where this power is a whole number integer. Now we use scientific notation because we want to represent very large or very small numbers in a very convenient manner. Without writing out a lot of zeros, we can use scientific notation simply to manipulate the decimal point and the power of 10 to represent the same number. So you probably have done this in a mathematics class at some point. We can manipulate the decimal point to change any number that is not in scientific notation to a number that is in scientific notation. So if we move the decimal place, for every decimal place we move it to the left, we have to increase the power of 10. So if we move our decimal place to the left, just say we have 800, and we want to represent that number in scientific notation, the implied decimal point is here. So to represent that in scientific notation, I would have to move that decimal place 2 places, and that would give me 8.00 times 10, and I've moved it 2 places. So that would be correctly 8.00 times 10 squared. So actually what you're doing is, every time you move the decimal point to the left, you're actually multiplying by a power of 10. You're actually multiplying by a power of 10. If we look at this again and we say 800, and I just move it to the left 1 position, then I will have 80.0 times 10 to the first. Now, if I move this decimal place again, that gives me 8.00 times 10 to the first times 10 to the first, and that's equal to 8.00 times 10 squared. So your laws of exponents say when you have the same base, you add the exponents. So that's what we're actually doing. The little shortcut method of increasing the power of 10, that is where that comes from. Now, conversely, moving the decimal place to the right, of a number. Moving the decimal place to the right, we have to decrease the power of 10 each time we move that decimal place. So for example, if we had 0.005, to get this into correct scientific notation, I need to move this decimal place once, twice, 3 times. So that would give me 5, and I've moved it 3 places to the right. So I have to decrease the power of 10 each time I move my decimal place to the right. And again, if we look at this example, I won't write it all the way out. This is correct scientific notation. Note that 5 is between 1 and 10, multiplied by 10 raised to some power. If I move this twice, I would have, let's say 0.5 times 10 to the minus 2. This is not correct scientific notation, number 1, because this number is not between 1 and 10. That number is not between 1 and 10. Now, essentially what we are doing, again, like we increase the power of 10 going to the left, we're decreasing each time the power of 10 when we go to the right. So what this actually is, moving this decimal place 3 times, the long-handed version would be 5. Moving it 1 time would be 10 to the minus 1. The second time would be another 10 to the minus 1. The third time would be another 10 to the minus 1. These are like bases, and I can add exponents. A -1 plus a -1 plus a -1 gives me a -3. So in a similar fashion, where we increase, we do the same thing when we decrease. So let's take a look at some of these examples that we have. Okay, we have all of these zeros and then a terminating 5. So I need to move my decimal place to the left a number of times in order to get this into scientific notation. So I need to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would be the number 5 times 10. I've moved it to the left 10 times. So that would be 10 to the minus 10. That is correct scientific notation. This number, 9,847.5674, this is not in correct scientific notation. However, I can move this decimal place 1, 2, 3 times. So that would give me 9.847, 9.847, 5674 times, I moved it 3 places to the left, and that is 10 to the third. This next number, I need to move my decimal place 1, 2, 3, 4. So my exponential is going to be 10 to the minus 4. I went to the right 4 places. So it would be 5.695040 times 10 to the minus 4. Number 4, this number, the implied decimal place would be here. So I need to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my exponential is going to be, I'll write that down here. It's going to be 10 raised to the power of 10. I moved it to the left. And the number is going to be 7.6849568454. So this would be the correct scientific notation. This number is indeed between 1 and 10. Multiplied by 10 raised to some exponential. So the common mistake that some students make is that whatever number we have, this has to be between 1 and 10. This number has to be multiplied by some exponential 10 raised to some power, but this number has to be between 1 and 10. 0.5 times 10 to the minus 15. This is not in scientific notation. We can put this in scientific notation. I can move this decimal and make it 5, moving it 1 place to the right, times 10 to the minus 16. So what I've actually done here is when I moved it 1 place to the right, I had 5 times 10 to the minus 15. Moving it that 1 place to the right gave me another power of 10 to the minus 1. When I add my exponents of like bases, I wind up with 5 times 10 to the minus 16. Okay, we will be using scientific notation and conversion factors and other problems throughout the semester.